Have you ever wondered how the cabling industry got started and how we ended up with the products and standards we have today? Who decided what it should all look like, how it should perform and how it should be installed? Hello everyone, Darren from i-LAN Technology. Welcome to i-LAN Technology's Introduction to Structured Cabling Principles and DINTEK Cabling Systems. This is part one of a four-part webinar series to give everyone a bit more information about the cabling industry and how DINTEK products fit into it. Today I'll introduce DINTEK as a company and go through some of their products. Then a bit of an overview about cabling standards and structured cabling systems, what they are, where they came from, and how they affect cabling manufacturers and installers. Okay, so DINTEK Electronic Limited is an award-winning manufacturer of copper and optic fibre structured LAN cabling systems. While not yet well known in Australia, they are well established in the Asian and European markets and have been for many years. The reason for DINTEK's ongoing success and popularity is not just having a quality product range, but by also supporting the products and their customers with in-depth installer training programs and an industry standards-based quality assurance system, as well as dedicated research and development. They don't just follow the market to be just another cable manufacturer, they constantly look at new ideas and develop new products in an effort to lead the industry in both quality and innovation. Founded in 1990, DINTEK is headquartered in Taiwan, where production is also based, manufacturing an extensive and diverse range of products from telecom connectors to backplane systems and LAN cabling systems. Here's a short tour of the factory in Taiwan. DINTEK now has a worldwide distribution network for their products. A second HQ was opened in Switzerland in 1999 to meet the ever-increasing demand for LAN products in Europe, the Middle East, Turkey and Africa, and on the Indian subcontinent. That's Bangladesh, India, Pakistan, Sri Lanka and the Maldives. The two stars here pinpoint the headquarters in Taiwan and Switzerland, while the dots represent all the distributors. There's a new dot now in Sydney. i-LAN Technology very proudly added DINTEK to our offering in late 2017. DINTEK is an ISO 9001-2008 certified manufacturing company, designing and manufacturing all products under the management of a core team in Taiwan to ensure the highest possible product quality and customer service standards are met. ISO is the International Organisation for Standardisation, and 9001-2008 is an industry standard that specifies requirements for a company to have a system in place to consistently provide product that meets customer and applicable industry requirements. The standard also includes processes for continual improvement. DINTEK employ rigorous quality control systems and close standards associations to assure the best possible product quality and performance. Ongoing research and development ensures constant advancement in both quality and innovation. DINTEK's products not only meet but exceed cabling industry standards. They have certifications from several well-known certification bodies like SGS, 3P, UL and DINTEK. DINTEK also recently submitted their range of Cat6 products to Oztest laboratories here in Australia, and we're pleased to announce that everything passed with flying colours. DINTEK also recently received an award for Best Networking Structured Cabling Products Provider Taiwan for the second year in a row from TMT magazine. DINTEK is proud to provide a 25-year warranty for a complete installation to be free from defects. That's for projects installed by DINTEK certified installers, with all components from DINTEK and all tests carried out per specifications. To achieve installer certification, DINTEK offers a DCI, that's a DINTEK Certified Installer Training course. The DCI course qualifies the installer to fit off and install all DINTEK products as specified in the ANSI TIA 568 standards for telecommunications cabling. DINTEK ran a DTI, that's a DINTEK Trained Installer course in Sydney for the first time in November 2017. The DTI is basically a shorter and less in-depth version of the DCI. DINTEK offers structured LAN cabling systems for Cat5e, Cat6, Cat6a, Cat7 and optic fibre. For each of these categories, DINTEK supplies not just the cables, but all associated components like patch panels, patch cords, jacks, plugs and wall plates, as well as tools and tool kits. Amongst DINTEK's extensive cable range is PowerMax 500 Cat6 UTP cable, pictured in the centre here. PowerMax 500 cable is constructed using 23 AWG conductors, which are thicker than usually found in Cat5e cable. That larger conductor size reduces heat generation and voltage drop over long distances, which results in better and safer performance, particularly when it comes to high wattage PoE devices starting to pop up now. PowerMax 500 cable also exceeds International Standards Class E channel specifications and has been tested to support 500 MHz up to 70 metres. The standard for Cat6 only requires support for 500 MHz up to 55 metres, so it's a little bit over-engineered. That larger conductor size in PowerMax 500 is very important when it comes to PoE. Back in 2002 we were introduced to 15.4 watt PoE under the IEEE 802.3 AF standard, which worked on 2 of the 4 pairs in UTP. Then we got PoE Plus in 2009, which could support up to 30 watts. Now we have 4-pair Type 3 and Type 4 PoE starting to appear on the market, which support devices from 60 watts right up to 100 watts. That's enough power to power stuff like desktop computers, smart TVs and that sort of thing. Sending that down cheap cable is asking for reliability problems, power loss and heat generation, which in some cases can even damage the cable. The 802.3 BT standard for 4-pair PoE hasn't officially been released yet, so there's a lot of different terms getting around for it, including 4-pair PoE, 4P, PoE++, UPoE, higher power PoE, ultra PoE and probably a few others. DINTEK have a wide range of jacks, plugs and fittings to complement each category of cable. Here we have a bunch of shielded and unshielded plugs and jacks. The faceplates pictured on the right are DINTEK's curver plate style, which come in either 1 or 2 gang versions. There's also 1 to 6 gang plates available in the standard US style, and DINTEK jacks are a standard size with standard clips, so will fit into pretty much any other brand of faceplate, even HPM and Clipsal plates with the addition of a bezel, which is kind of an adapter, pictured on the bottom right here. And a range of patch and management panels including half U size. DINTEK also have shielded and cassette patch panels for Cat6a and Cat7, as well as standard patch panels for other categories, and management panels. And of course cables and patch leads, which come in different lengths, different colours, with either a PVC or an LSZH cable jacket. LSZH stands for low smoke zero halogen, which means it emits limited smoke and no halogen, that is toxic fumes, when exposed to high sources of heat or fire. One thing you don't want in a fire is a cable that acts like a wick and transfers the fire into other areas, or takes people out with poisonous fumes as it burns. PVC is slightly cheaper and more flexible, but if it's going into a populated building or an enclosed area where people can't always evacuate quickly, it's better to run with LSZH cable. Some building codes in many areas might also require it. PE, polyethylene, is another type of sheath for cable. It's more weather resistant and UV protected, so better suited to outdoors or oily or corrosive environments, in factories and other industrial type environments. DINTEK has a great range of tools and testers, including the Tech Bench pictured on the right here, which won an International Gold Award at the 3rd Annual Cabling Innovators Awards, run by Cabling and Maintenance magazine at the Bixie Conference in Las Vegas in 2017. The Tech Bench is basically a toolbox which folds out and clips to the front or back of a rack in seconds to create a sturdy and comfortable working surface. Little niceties like cable guides at the back and pins at the front to hold a patch panel in place while you're working on it make an incredible difference when working in what are usually quite confined spaces. You can see it in action on DINTEK Taiwan's YouTube channel, and I'll also include a link in the description below. No data cabler's toolkit would be complete without a pairs tester, also known as a continuity tester. These basically test for common problems like shorts, open circuits and incorrect polarity on both patch leads and full cable runs. One standout tool from DINTEK is the EasyTool 90 for horizontal easy jacks. The EasyTool 90 basically punches down and trims all 8 wires at once, which is much quicker and easier than punching them all down individually. There's also the EasyTool 180 available for terminating vertical easy jacks in the same manner. We'll also need some side cutting pliers, cable strippers and the DINTEK Keystone Jack working base. The working base is a rather neat little device to hold a keystone jack in place while you're working on it. It has 2 slots for horizontal jacks and 1 for vertical jacks. DINTEK Easy Jacks have the colour code displayed inside the jack. Today we're using the T568A standard, which is the standard we use here in Australia. That's displayed in the centre 2 columns inside the jack. First we need to strip off some cable sheath. About 50mm is usually enough, but it doesn't matter if you strip off a bit more than that. Cut off the excess cord. Separate the wires and cut out the central spacer. Line the cable up in the jack. You want the edge of the cable sheath as close to the jack as possible. Pushing the pairs hard up against the post in between the 2 IDCs and then giving the wires a wiggle will usually get them far enough apart to get down into the slots. You really want to avoid untwisting the wires inside the jack. If you're having trouble getting a pair around the right way, you're better off putting another twist in rather than untwisting them inside the jack. Insert into the EasyTool 90 and crimp. The final step is to put the cover on. Now these are quite important to prevent any of the wires coming loose as the cable gets moved around. And job done. Another product I really love that I think helps DINTEK stand out from the crowd is the RJ45 Passthrough Easy Plug. Here's a video showing the RJ45 Passthrough Easy Plug and crimp tool in action. Okay, the first step is to slip the boot onto the cable. Strip off around 50 or so millimeters of sheath. I'm using DINTEK's Cat 6 unshielded cable here. Cut out the ripcord and the central spacer. Untwist the pairs. Straighten the wires out using a screwdriver or the handle of another tool. Sort the wires into the right order. I'm using the T568A standard here, which is the standard we use in Australia. Give the wires a trim so they're all even. Now push them all the way through the connector. One of the big advantages with the pass-through connector is that you can easily see all the wires have made it all the way past the contact points and that they're all still in the right order before you crimp. Push the boot into place and crimp and trim the wires all in one action. Another big advantage with pass-through connectors is that the twists end up much closer to the contact points compared to standard plugs. That's a performance advantage, especially when it comes to Cat6 and above cables. Incidentally, the boot I'm using here is one of DINTEK's Easy Lock boots. These have a removable tab to prevent the cable from being unplugged accidentally. On to fibre optics. DINTEK has a complete range of fibre optic products, including fibre optic cables, connectors, enclosures, adapters and couplers. And fibre patch cords, even cassette patch panels for data centres. The Easy Fibre Connect system on the right here is a toolkit which uses quick and easy mechanical connectors instead of old school glue and polish types. It especially comes in handy in an emergency situation. It can replace a broken fibre connection and get everyone back online without expensive tools within a few short minutes. The kit includes everything needed to quickly and easily fit off Easy Fibre single and multi-mode quick connectors and mechanical splices, including the Easy Fibre cleaving tool, fibre strippers, Kevlar scissors, a fibre checker, an alcohol bottle and wiper, 10 mechanical splices and Easy Fibre SC connectors and more. Here's a video showing the Easy Fibre Connect system in action. DINTEK Easy Fibre Mechanical Fibre Connector Demo. We'll need a few tools including cutters, cable strippers and the Easy Fibre cleaving tool. Start with plugging the fibre checker into the good end of the cable. This just sends light down the cable to make it easier to see what's going on while you're working on it. Cut off the dodgy connector, blame the apprentice for that one. Before we strip the fibre back, remove the screw and back piece and rubber boot from the connector and push it onto the cable down out of the way for the moment. Strip off the outer coating about 10mm at a time until you've exposed about 40mm. That way it fits across the width of the cleaving tool. And cleave. The cleaving tool ensures the exposed fibre is cut to exactly the right length for the connector. Watch where the rubbish goes. Give it a good clean with an alcohol wipe. Stick it into the connector, making sure first that the locking tabs are pulled out. Nice and easy, don't try to force it. You'll know you're home when the light comes out the end properly, then push the locking tabs back in firmly. Push the rubber boot back in under the clamp, screw on the back of the connector, finally attach the boot cover. Job done. Now let's take a look at cabling standards to find out why DINTEK and other cable manufacturers make things the way they do and why installers do things a certain way. What is a standard? A standard is a published document which sets out specifications and procedures designed to ensure that a material, product, method or service is fit for its purpose and consistently performs the way it was intended. Back in the early cabling days there were lots of different proprietary systems getting around and it was starting to get seriously out of hand. So manufacturers got together to work out a solution that would work for everyone, as long as everyone agreed to stick to it. And so cabling standards were born. The purposes of standards is to firstly support a multi-vendor environment. So for example, I can now go to multiple shops and buy one brand of cable, a different brand of connector, a different patch panel, and even different patch cables, and know that they're all going to work together. Next, it enables uniform planning and installation. So in a given installation, we now know we're going to need to use a certain type of cable, certain types of connectors, patch panels and so on. We know where it all goes, and if we install it correctly, it will all perform as expected. And finally, to establish performance and technical criteria. So if we need a certain level of performance over a certain distance, we know what to shop for. The scope of cabling standards is to firstly set minimum and even maximum requirements, i.e. what we need the products and infrastructure to do. Our media parameters, what applications and types of media we need to run over it. Our topologies and practices, how we design and construct our infrastructure, for example ring or star type topologies. Distance limitations, manufacturers need criteria to create products that are neither underpowered nor overpowered to do the job. There's not a lot of point creating a whiz-bang cable that can span 400 metres if the vast majority of horizontal cable runs are well under 100 metres. It'd be needlessly expensive for starters. And standard connector and pin assignments to ensure interconnectability by different media. So whatever we want to plug into a network, we can be reasonably sure it's going to fit and it's going to work. Who decides what the standards should be? This table outlines the hierarchy of standards organisations throughout the world. Top of the tree is ISO, the International Organisation for Standardisation, which has its headquarters in Geneva, Switzerland. Standards Australia and Standards New Zealand on the left there work together to develop joint standards under AS/NZS. Standards Australia, incidentally, is also the principal sponsor of the Australian International Design Awards. IEC is the International Electrotechnical Commission, also with its headquarters in Geneva. CSA is Canadian Standards Association. CENELEC is European Standards. Up the top right-hand corner of the diagram, I've put the box with the words used to create that acronym. And over on the right, we have the American National Standards Institute, ANSI, and the TIA, the Telecommunications Industry Association. The bottom half of the diagram is all the individual country standards, which cover pretty much the same thing, which is generic and commercial telecommunications cabling. ANSI TIA is the most popular internationally and the most closely adhered to by manufacturers, which is why we generally refer to TIA 568 with our cabling standards here. ANSI TIA 568 standard covers all of our main cabling standards. Within it we have four main components which can be grouped into three categories: common standards, premises standards, and component standards. 5680-D is about generic cabling and details the type of cable to be used in each situation and how it has to be installed, our topologies and practices and so on. Below it we have ANSI TIA 569C, which is pathways and spaces, how we install cable, cable trays, ducting, power separation and so on. TIA 606B is administration standards, that's our documenting and labelling. 607C is grounding and bonding. TIA 862 is building automation systems cabling, and ANSI TIA 758B is outside plant, OSP, infrastructure, that's our underground and overhead cabling. Under the premise standards in the centre column, we start with 568.1-D, which is commercial premises cabling, where we start getting into structured cabling and subsystems for each building component. And under component standards in the right-hand column, we have 5682-D and 5683-D, which is balanced twisted pair cabling components and optical fibre cabling component standards. So what does a structured cabling system look like? Well, if we look at it from its generic standpoint in 5680-D standard, that's our common standards column, it looks like this. From left to right here, we start with a campus distributor, that's the CD, which would be in some sort of central building on a campus, to a building distributor, that's the BD, in every building on the campus, to floor distributors, FD, on each floor in each building. It possibly might have a consolidation point, the CP, somewhere in the horizontal cable run. A consolidation point is something you won't actually come across very often though. It basically creates a location for interconnection between horizontal cables somewhere within the cable run. It might come in handy where the last section of cabling might be susceptible to damage to make it easier to replace that section rather than the whole run, or in situations where the outlets might need to be frequently moved around. It's similar but not the same as a floor distributor. It's more of a passive device rather than an active device, so we'd be looking for a termination block rather than a patch panel. And finally at the end are our telecommunications outlets, our TOs, which are our wall plates that we plug our workstations and phones and so on into. This diagram gives us a bit more detail for a multi-floor building. So here we can see our campus distributor in a separate building on the left, feeding to the building distributors in multiple buildings on the campus. Our particular building here on the right has 3 floors, so its building distributor on the ground floor feeds to a floor distributor there, and to 2 more floor distributors on the 2 floors above. A floor distributor might be as simple as a wall cabinet with a patch panel and a switch in it, or it could be a whole room with communications written on the door. Then each floor distributor feeds to the telecommunications outlets, which are our workstations, phones, network printers and so on. In most cases these days, our backbone cabling between the campus distributor and each building distributor will almost certainly be optic fibre. The backbone cabling from the building distributor to each floor distributor, also sometimes called vertical cabling, will also usually but not always be optic fibre as well these days, and our horizontal cabling out to the workstations will almost certainly be UTP. On to structured cabling, which falls under the ANSI TIA 568.1-D standard under our premises standards category. A structured cabling system is defined as a set of cabling and connectivity products that integrate the voice, data, video and various management systems of a building, such as the safety alarms, security access control systems and energy systems and so on. Why do we need it? We need it because we have an industry with so many different components, so many different operating systems and so many different applications. It's necessary to try to combine them all and get everyone on the same page. One of the advantages in having a structured cabling system is that it provides a standardised cabling infrastructure throughout a building or campus. That means I can show up on a site I've never been to before and expect to find a certain infrastructure in place. You can probably also imagine the problems that might come up if a cabler installed a unique one-of-a-kind system and then got hit by a bus or something the next day. Wouldn't matter how awesome the job was, it's going to become very painful for the owner and the next cabler who has to work on it, and probably within a very short period of time. Next, it's a flexible cabling system without regard to its ultimate use. So it should support anything we want to plug into it, whether it's an IP camera, a Windows computer, a Mac or a Linux device or whatever. We can use it for voice, data and even video without needing multiple cable systems anymore. Similar to the previous point, whatever we want to plug into it, whether it's a phone, a computer, a smart TV or whatever, it should still work on the same cable. It allows easier adds, moves and changes. So if a user moves to a new office on a different floor, the phone and data cabling can be repatched to the new location without the need to run new cables. And a structured cabling system should also allow upgrading to different network types. This hasn't really been an issue within the last decade or so, but for any new stuff produced in the future, manufacturers now know what needs to be done for it to be backwards compatible with existing products and infrastructure. Under the ANSI TIA 568.1-D standard for premises cabling, for commercial buildings the structured cabling system consists of 6 separate subsystems, which are number 1, the entrance facilities. This is where the cable enters the building from outside. Number 2, to our equipment room, which contains the main building distributor where we'd find our switches, servers, routers and PABX systems and so on. Number 3 is our telecommunications rooms, which are our floor distributors, basically more switches and patch panels for each floor or area. In this example, our telecommunications rooms are just wall cabinets. In a larger building, they'd be actual rooms or perhaps a full-size cupboard, usually somewhere near the elevator. Number 4 is backbone cabling, which is the term we use for the cabling that connects buildings together, and also the cabling that connects the floors down to the equipment rooms. Number 5 is the horizontal cabling, which is used to distribute out from the telecommunications rooms to the individual workstations. And finally at number 6 is the work area components. So these are our wall plates and patch leads and so on, connecting the computers, phones, IP cameras, etc. into the network. Any part of the structured cabling system will fit somewhere inside one of these subsystems, and the standards have specific requirements for each of these areas. So that ends our webinar at this point with what I hope has given everyone a bit of understanding about DINTEK and how the products fit within the cabling standards. In our next webinar, we'll start looking at these subsystems in a little bit more detail, starting with the entrance facilities, and we'll also look at optic fibre cables and connectors. For more information about DINTEK products, please visit our website at www.dintek.com.au, or you can send an email to sales@dintek.com.au. Don't forget to like and follow us on social media. You can find us on Facebook, YouTube and Twitter under the DINTEK Australia name. Thanks everyone, and bye for now.